So hey guys, welcome back to my channel. So guys, today I will be doing an internship task. So today I will do an internship task where I am doing an currently a virtual internship program of 1 month, and this company is a course of company. So yeah, this is the company where I got an internship offer letter. This is a virtual program where this duration is of 4 weeks. So so today I am going to do an internship task based on Titanic survival prediction. So, if you are new to my channel, so you can check my intro. What I'm doing is in this channel, I will be uploading a data science project, data science ideas, or data science task. So, today I will be doing an internship task that is an task of Titanic survival prediction. So, this is internship offer letter, and this is my GitHub account. So, so for the task given, we will first analyze the data, what the data is. So here we had given the passenger ID, survived, P class, name, sex, age, sibling spouse, parent child, ticket, fare, cabin, and embark. So passenger ID is the number, the unique ID, unique number. Survived is our target variable where we have to predict the survival of the Titanic. P class is the class, first class, second class, third class. Name is unique for all. Sex is that is male or female. Age is the specified that from is a continuous number. Sibling spouse means is having a sibling spouse or not, parent child having or not. Ticket price is there. Fare, cabin, cabin is like cabin is like C85, like our train seat number, bogie number. And come here, embark. Embarked is the categorical value that is S, C, and Q. So we will go in deep in coding section. So yeah, going into the coding section. So the problem statement is to build a model that predicts whether a passenger on the Titanic is survived or not. So for any data science project, we require these steps like data gathering, whether it's from API, web scraping, secondary or primary data. So then we come on to the data cleaning. Data cleaning, which includes handling missing values, remove duplicate records, detect and treat outliers, correct and inconsistent data. Then comes data transformation, feature scaling, feature encoding, feature engineering, dimensional reduction. Then data integration, reduction, data normalization if is there for improved efficiency and accuracy. Then data splitting would be there, training, interesting, validation data, data visualization, some for EDA purposes, exploratory data analysis, and some for the documentation purposes, we keep it. So now we import the libraries required to import the dataset, and we had also import the warnings if have any, we will ignore it. So I had imported the data and this is the data. So we will just describe the data first what it is. So here we can see that age. Age is having the mean of 30, 29.69 means we can take 30. So average the age of the people are having 30 age. Then yeah, this we can describe from here. Info. So data frame info here we see that five integers we are having, two floats we are having, and five objects we are having. And there are missing values in cabin. In cabin we are having, in embarked we are having, and in age we are having. So so now we will remove the columns which are not required, such as passenger ID, name, ticket, cabin, which is irrelevant for our survival prediction for now. And now we keep it as here. Now we having survived, P class, sex, age, sibling, spouse, parent, child, fair and embarked. Now, now we see the info as we have two columns having missing values where embarked is having less than 5% but age is having more than 5%. So if we see that embarked is having two missing values and age is having 177 missing values. So for embarked features having less than 5% MCAR, which means missing completely at random, so we can drop it, which won't be affecting the data. So we have dropped it. So now we remove the missing values of embarked attribute. We will proceed on to the next attribute, that is age, which is having 20% missing values and MCAR. So we have to impute it because if we remove the data consistency will not be there. So we will impute the missing values. So for that we will just check the missingness reason, because missing how the values are missing, we should also check that. So for that we are checking the distribution of how the age feature or age attribute is there. So age attribute, if we see, yeah, age attribute is having somewhat normal distribution. Somewhat normal distribution we are having in age attribute, and in fair, if we see, in fair we are having right skewed because this part is the more bumped area and this is a skewed area, right skewed. And if we check the outliers in the age attribute, yeah, outliers are there in age attribute, and in fair attribute if we see, in fair attributes are also there. So for removing outlier, we are using a transformation like logarithmic transformation or square root transformation, cube root transformation. But it is based on the distribution purposes, like if it's a right skewed or left skewed or kurtosis is there or not. It's based on that. So here I am having the right skewed in the fair and age is having somewhat normal distribution. So I have used here in transformed age is having a square root, whereas fair is having logarithm transformation. And after transforming the outliers attribute, the new distribution is looking like this. And for age, outliers are somewhat, age attribute is somewhat reduced, we can say. And in fair distribution is somewhat is having normal distribution. And here also outliers are somewhat reduced. Now if we see the data frame, the data frame looks like this, where fair is having the range of 1 to 5, or it's a logarithmic transformation, and same as to goes to age also, where age was having the values from 20 to 40, 20 to 60, but now it's showing as 4, 6, 6.5 and all. It's a float value. So we have transformed the age attribute also. Now we will see, now we comes to categorical to numerical representation conversion. So the attributes which are having categorical values, data sex and bar, and we will implementing one hot encoder so as having a perfect order or rank, because here if we see sex and embark, here we are not having such a order. For example, if I want to say that yes, if I want to say that P class, so P class is having first, second and third only. Here I can say that first is a first class, second is a second class, third is a third class. But here I cannot say that sex is having, male is having first rank and female is having a first rank, or we can say embarked is having C, Q or S is having first rank and all. But so yeah, so we cannot say that it's having ranked values. So we are here implementing one hot encoder. So one hot encoder here we are implementing for categorical values. So how one hot encoding will be look. So if we see a male, if we see a sex attribute, it is having only two values like male and female. So our data will look like this. Sex attribute will be removed, and male and female attribute will be formed, and it will be denoted as 1 and 0. If it's male, it will show 1, and if it's not, then it will show 0. So this makes the this makes the data columns increased, but it makes the model much more efficient because category values it don't take. If it takes much more better, but it don't take. It takes only continuous representation or continuous values. So we are encoding here categorical values, which is sex and embarked. Now we are removing missing values because it does not take missing values. Now we are initializing the one-hot encoder where I am talking first. Then encoder fit transform I am doing, and I am creating my attribute name as my attribute name underscore and my value name. For example, sex underscore male, sex underscore female, like this. And I set as a reset index, and last I concatenated that data into my original data frame, and the data frame looks like this: sex male, embarked Q, embarked S. And you are confused, like you are thinking like, how, where is the sex female, where is the embarked underscore C. So here we had used one hot encoder, but we had also used here drop first, which means it will remove that column where it will remove the first value. So which means that if a male female attribute is there, if one is there, obviously it would be zero in second one. So we are dropping at first. So we dropped here at first. Oh, it got wrong because it is a interpreter. This is a kernel, no, so it got wrong. We have to again restart it. As it is an interpreter, we should be careful while implementing line by line. Yeah, now it is done. Now we can see that sexmail embark Q embarked as, and we are seeing that 101010. If it's true, it will be showing 1, and if it's false, it will be showing 0. Now if I see the data frame, is it having any missing values? Yes, it's having. It's having in age. So as the missingness is completely at random of for 20%, we prefer it to impute through model-based imputation. So what is model-based imputation? If I say we have to train the data through missing values, we will train the data through the filled values, and from that attribute or features, we will predict the missing values. So we will use a linear regression imputation so as to it will impute based on the data itself. Now we are imputing through linear regression and simple imputer, where I am removing that age attribute missing values and data without age I am having, and we are training the data X train Y train using the linear regressor and fitting the into X train Y train, and we will predict the age through that through that field values. We will predict the missing values, and it will fill the missing values with the predicted field values. Yes. Now if we see that it's having missing values or not, it's not. So we had filled the missing values. Now second step is we have to check the duplicates are having or not. It's having duplicates, so we will remove the duplicates. And yes, we had removed the duplicates. As we can see that we were having triple one, we were having 889, and duplicates were triple one. If we minus it, we will see 778 rows. Now we will come to visualization part, and we will do some exploratory data analysis. So we will use a matplotlib as a library and cborn as a library, and we will see the count plot, how much male has survived or female has survived. So we can see here that males are survived. No, no. We can see here that males are not survived, but females are survived because here we can see blue is 0 and male is having much longer graph, longer bar. So we can say that we seen that most of the males are survived, which means the rescue team saved most of the female passengers, obviously. Now we are seeing the count plot of P class against survived. So we can see that third class, third class are having the greater chance for not survive. So which means we can say that the class third class was uh, in the lower deck. So if I so according to the graph, we can say that the third class deck of ship are not survived. So we can say that the probability of surviving of passenger would be mostly from first or second only. And if I say that if I see that here here the ship is having the third class which is pink one and this one. So we can say and the ship was broken from the middle. So ship was broken from the middle. So the chances of getting not survived is of third class only. So this is the structure of image where it's clearly seen that after crashing the ship breaks into two from middle and the back class are highly affected, that is third class. And we can also say that the class is having a high relation between their survival. So now the data frame looks like this: 778 rows is having missing values, that is not. Now we are doing feature engineering where if there are siblings, spouse and parent child, and if it's having more than one, we can say it as family, or we can consider the two attributes as family. So I merge the two attributes and make them as a family, and there is a condition I have put like if it's equal to 0, then which means they are alone. So now I dropped sibling, spouse, and parent child because I have already created the new features like family and alone. Now I am creating a box plot of data frame which is having quite outliers in family part, embarked part, age, and fare. So if I talk about the regression algorithm are less sensitive to outliers, so we can ignore it as it's very less sensitive. So we are now doing a standard scaler because here if we see our graph data frame, yes, here we are having 4 point something, 2 point something, and rest is 101010. So I had scaled the age column so as to get in the range of 0 to 1, and I had created the standard scalar function here over here and fit transform the column, that is age column. Now here there are some outlier, but we are saying that we are using the model which is regression model. So here we can say that it's not sensitive much to outliers, so we can neglect it. Now we are creating a correlation matrix. So correlation matrix we are created, and we are dropping the correlation matrix with survived because survived is our target variable, and we will create a heat map on the basis of that. So this is a heat map, and we can see that the most features, if we say that 0.31, then 0.51, then yeah. So these 2 to 3 features are mostly related with each other, or they have most covariance with each other. Just we can see that correlation with target is having these values. Having said that, which are having much more values greater first 3 or first 5, we can consider that. And now I had created a threshold that if it's under this threshold, we can consider it as a selected features to train and predict the model. Now take I have taken the features like P class, age, fair, sex male, and this is also based on the opinion and domain knowledge. So how it's come across the domain knowledge. So if I say that the P class, so P class is having the much more chances of getting not survived. So I taken that. Age. If a rescue team comes, we can consider that age of having age like 0 to 10, and 0 to 10 are much more likely to be survived because they will first survive the babies than the adults. So that's why age is also matter. Fair, if I say that fair does not matter, but it's showing the variance also higher than the other attributes. So we are considered this also. And sex male. Sex male is there because the females are having much more correlated between these attributes with survive. So that's why taken with this, and I had kept in the x variable and y variable as a dependent variable in survive. Now what is my x? This, and what is my y? The survive part. Now I had to split into train and test part, which is x train x test, y train y test, and my test size is 0.2, which is 20% will be my test size, and 80% will be my train size, and random state will be 42. Random state means it will take it as a random and it will predict it. Now I will see my X train. So X train is my this. Now I will go for model selection. So taking as a logistic regression, taking into consideration for model training, because logistic regression is one of our classification algorithm. It's having output of 0 and 1. So I trained it and checking the accuracy on the basis of that. And yeah, if I check the accuracy, it's coming around 78%, which is which is normal, means which we can't say that it's very accurate or it's very low, but it's average. We can say that it's average, it's running properly, or it's not fully properly, but we can say that our model is working and it can predict 78%. And if I say the cross validation is also coming around 78%. And confusion matrix is having this, which means that actually that if I am predicting this, that actual value and the predicted value, so I'm getting this, and predicted value is getting this. So this is for my logistic regression. Now I consider that if my this model is not working, I should go on to the next model, because it's not possibly that possible that if it runs only on the one model. So I'm going on to the second model, that is decision tree. So taking into consideration of decision tree. So took the decision tree classifier accuracy score as to import the libraries, and I am I am fitting the model into the decision tree and predicting it. Now, if I see my accuracy score, it's coming around 72%, which means that it's not working much accurate than my previous model, that is logistic regression. And my cross validation is also coming is around 76%, which is average. So I thought of taking an symbol algorithm. So took the what we can say took the algorithm like XG boost. So XG boost means extreme gradient boosting to classify the prediction model. So I import the XG boost from the XGB classifier, and the rest are same. And here I can see the accuracy is 76.9. So 76.9 is my accuracy, and cross validation, if I see, it's coming around 78 point something, and confusion matrix is this. So these three were the models I am having as a coming around 70% So now considering the random forest model, so for that random forest I am using for the classification algorithm. So I had imported assemble and imported random forest classifier, accuracy score in classification report, confusion matrix, and cross validation score, same as the above. Now I run the model and printing the accuracy score. which I am getting 80%, and it's running properly, or we can say accurately than others. So here also I am getting 80%. So we see in the four models, that is logistic regression, decision tree, XGBoost, and random forestry. And we notice that random forestry classifier works well with accuracy of 79%. Here we are seeing 80%. So it's having accuracy of 80% and cross validation score of 80% only. So we can say that our model is predicted well in the model of random forestry, and it completed our motive. The motive was to predict the Titanic, to predict to build a model that predicts whether a passenger on the Titanic is survived or not. And this we completed our problem statement to build a model that predicts whether a passenger is survived or not on the Titanic dataset, having parameters like age, sex, embark, P class, and family. So this was my first task. So if you want to refer the code or something, if you want to show the correction, like if we are having changes, or we can scale the code or not, scale the feature or not, feature encode we can do or not. So you can comment it, or else I have my GitHub uploaded also. So this was my course of internship, and in the course of writing survival prediction was my writing survival prediction was my task one, and it's completed. And this I had uploaded my task one project. So it's taking time. So same code I have uploaded here. Yeah, same code I had uploaded here. So if you want to refer it, or if you have any corrections or changes you would like to say, you can comment me on the YouTube. You can comment me in the comment section. And this was my task one. In the next video, I will proceed with task two. That would be on the that would be on its movie rating prediction. So we will go for the movie rating prediction with Python in task two, and we will complete it in the next video. So this was my first task in this channel, and yes, yeah, thank you. And if you like this video, you can subscribe me, like this video, and share for this same coding related data science projects and tasks. And if you have any suggestion, you can comment in the comment section. Thank you.